finally time to talk about slicing in Python. Slicing allows you to access one or more elements from some kind of sequence. I've had to hold my tongue while discussing the sequences earlier, where we have immutable sequences such as tuples, strings, and bytes, and mutable sequences like lists and byte arrays. Slicing applies to being able to work with all of these types, and with the mutable type, even modify that sequence. As usual, on the left side of my screen, I have a Python shell, which I will use to run my program that I have on the right side of my screen, which in this case is called slice_demo.py. Let's go ahead and run that program with run menu, run module, and we'll see how slicing works. First of all, we see just some examples of those immutable sequences like a tuple, a string, a byte sequence, as well as mutable things like a list and a byte array. The first thing to know about slicing is that you can use square brackets after the name of the object and put a number in there. The number is an index where 0 refers to the first element, 1 would refer to the second element, 2 to the third element, 3 to the fourth element, and so on. So we see in the output here the very first element of a tuple, the second element of a string. In the case of bytes and bytes array, they return the byte value of that particular element. So Q must have a byte value of 113. You can see that fourth element in a list, which is 8. The fifth element in a byte array, which means that that B must have a byte value of 98. You can also use negative slicing, where negative slicing works its way from the end instead of the beginning, where -1 refers to the last element, -2 the element before that, and so on. So we can see with -1, we have that last element of a tuple, which is a tuple itself, 3, 4. Or -2, the element just before the last one in a string. Again, we have a byte value returned from a bytes. For the third element from the end, 6 is returned. For the fourth element from the end, and 116 returned for the fifth element from the end. And again, it's a byte value of that particular character. If you use 2 indexes, then you can get sub-slices, or multiple elements shown. By using 0:2, I would read this as start at element 0 and go up to but not including element 2. Another way of looking at this is we might consider the first index to be 0-based and the second index to be 1-based. Looking at a list between 0 and 2, we start at 0, go up to but not including the element with an index of 2. So we'd end up with those first 2 elements, 5 and 6. Now, if you want to start at the beginning, you can omit the 0 and just use colon and then the ending index. So notice the result is the same. Likewise, if you're going to refer to the index just beyond the end, where here we have 0, 1, 2, 3, 4, 5 is beyond the end. Remember, it's up to but not including that. This would give us from the element that has an index of 2 all the way through the end of that sequence. Instead of including that element that's 1 beyond basically the end of your sequence, you can just omit that and use your starting index colon and not specify the ending index, and it will go all the way to the end of the sequence. Now, if you use both an omission of the starting and ending indexes, then it creates a copy of the entire list. Now, it's important to note why you might do this. If you create an assignment of a variable to an object, it creates a reference to that object. And since a list is mutable, if I were to change a list, it would appear changed in the reference to the list as well. You can use the is operator to see if two different references refer to the same object. And since a list is list_ref is true, if you were to modify a list, effectively you'd be modifying what you would see in list copy. By having a reference like list_ref equal a list, if you modify a list, then effectively you would be modifying the list_ref list as well by creating a copy by using that what I call full slice notation. You get a copy of the full slice. Then this is a separate object that does not refer to the same object as a list. And if I modified a list, it would not affect the elements that are in the list copy. And you can see using the is operator to test if these two names reference the same object, it's going to be false. By using a third parameter, you can specify an interval or a step that's taken between each slice. By using : 2 for the slice notation, it will pick up every other element. And since the whole A list shows this, we see 5, that first element, 7, the third element, and 4, 5, that fifth element. So it's going every other element to create that sequence. In addition, you could start at a particular index and stop at a particular index and specify a step as well. So in this case, we start at index 1. We go up to, but not including, index 4, not including this, so we'll stop here. And we take every other element. So we'd end up with this sequence here. Kind of a special case of using the third parameter in slicing is using -1. In effect, this will reverse the sequence that you're using. In this case of a string, we see a mutable reversed to be spelled backwards. If you have sequences within sequences, you can use additional slices to access those elements within those sequences. In the case of a list, we see it has a sequence 4, 5 in index position 4. So by slicing index position 4, we get that tuple. By slicing again after the 4, we could access the first element of the tuple with an index of 0, or the second element of that tuple with an index of 1. If you have a mutable type sequence, that is lists and byte arrays, then you can update your sequences with slices. First of all, we see what a list looks like before making any updates. Then we see updating a list index 0 here, or slice 0, to be the word 5 instead of the number 5. And you can see that that has actually updated a list. You could also specify by a starting and an ending index multiple elements that you want to update. In this case, those elements starting at index 1, going up to but not including index 4, would then be changed to the elements 10, 11, 12. So you see the 6, 7, 8 got updated to 10, 11, 12. Finally, we might mention that there is a slice object that you can create if you want to use that for slicing. So that you don't have to use fixed numbers here, you could go create a slice object using the slice function, specifying a stop index perhaps. And you'd see that that slice just only has a stop, no start or no step. And then you can use a slice to specify what slice you want instead of using the numbers separated by colons. So this goes up to, but not including, slice 4. So we have element 0, 1, 2, and 3 shown. You could specify that starting and up to, but not including, that ending slice. In this case, we see the slice starting at 1, ending at 5, having no step. And so then we would be pulling in elements 1 up to, but not including 5, which is beyond the end of the list. So really it stops at 4. And being able to display that slice. And finally, you could do all 3 parameters, a starting, a stopping, and a stepping value, and use that to create your slice. In this case, starting at index 1, going up to but not including index 5, and stepping by 2. So we got every other element from 1 going up to but not including 5. Hopefully now you understand better about working with slicing in Python.